We just finished up a project for a beverage distributor. It was about 2,000 feet of Hytrol conveyor and about 800 feet of blue aluminum rapid air pipe for the pneumatic system. It almost took a month for the mechanical side of things with a bit more time for startup support. So let's take a walk through some of the details that make up a quality installation. The guys like tensioning these belts by elongation because it's one of 10 things you can do to cross all your T's, dot all your I's, and know that you're leaving site with nothing that could go wrong on these belts. You got to make sure you have no loose ends if you want to prevent any return trips. Those are annoying and costly, and it gives you a bad name if you do this for a living and you can't foresee what's going to go wrong. Butt coupling bolts shouldn't be long enough to be in the way of pop-out rollers. This one's scraped by the hair of its chinny chin chin. Anytime you have a slotted or oversized hole, you should have a washer. But not on the serrated flange nut side. That would negate the serrated locking function. The flange is there for the slotted holes. Holes the same size as the bolt, no washer. And you only need 2 bolts on supports, just like ceiling hung conveyor. These 2 holes are for your alignment pin to get that metal out of the way when you drop this bolt in. You'd waste a lot of time if you tried to put extra bolts in here. You'd have no place for your alignment pin. We put 1 bolt on butt couplings when it's floor supported and 2 when it's ceiling hung. You know, if you're using 3/8 lags on this resin deck, sometimes you run into stuff you can't get the lag to go through the hole. So these 1/4 inch by 1 inch on a fender washer are really nice. And you don't have any equipment up here running into the conveyor, so you don't have to worry about it being too light duty. I've seen them after a decade or 2 and they're still holding the conveyor right where it was set. It's nice to have the belts track so well after you've installed it correctly. So let's run through a few of the things that lead to a proper installation. You build the conveyor with only hand-tight hardware because you still have to do some adjusting. You level all the conveyor along the length and across the width before you straighten it. And that's critical because if you level across the width after you straighten, you're going to actually change where the top of your conveyor sits in relation to the rest of the conveyor. The taller your conveyor supports, the more drastic that is. So level, straighten, then square all your beds within a 1/16 of an inch, and then double check that it's straight right before you anchor everything. After you've done that, then you can go back and tighten all your assembly hardware. And sometimes after you've run the conveyor, you have to slightly adjust those turnbuckles a little bit more to get those beds perfectly square, because you can only get them within a 1/16 when you're measuring to make the bed square, and the roller holes may be punched off a 32nd and other different tolerances that you can't account for. If you do have to adjust those turnbuckles while the conveyor is running, it'll be very slight because you've already got it pretty close to square when you are measuring. Once you've squared all your beds and you've tightened your hardware on the supports, each corner of your bed is tied down to the support, so you don't have to have these turnbuckles on anymore. I like to let the electricians know they can take that cross bracing off if they need to mount a power supply or IOP somewhere near it. But for ceiling hung, I like to keep 2 on each bed section if you can. Maybe take some off the floor support and put them up there. Keeps it a little more stable over the years since there's more movement up in ceiling hung. When lacing your belts, ignore any extra teeth on the sides and instead align the sides of the belt when putting the pin in. The air for ABEZ is set at 35 PSI, and we got a Rapid Air Products blue aluminum fast pipe system that we put in for this project. And then we have 1/2 inch ID drop hose with 1/2 inch NPT female swivels. That way it doesn't twist up the hose as you're trying to take it on or off the FRL. And then 3/8 ball valves. There are 10 different reasons why you'd want to be able to shut off air at each FRL for your convenience. And then coming out 3/8 poly teeing into the 3/8 along the ABEZ. Of course, you're mounting the FRL pointing into the conveyor so people don't hit it with their legs. Any conveyor that's going to be worked along, you don't want to have your flex hose coming down right in front of the conveyor where they're going to be working and throwing boxes on. So here in the mezzanine, you can have it come through the floor and then to your FRL. If you're at ground level, you can drop down with flex hose at the end of your pick mod and then run along the conveyor until you get to the middle with your FRL. Whenever you have a short bed like 5 foot that you have to square, the turnbuckles aren't small enough for that, so you can just use a ratchet strap And then before you let loose the ratchet strap, tighten your hardware on the supports. When squaring a drive bed, you have to loosen up a lot of hardware. So you have to crack loose all your bolts that hold the drive to the bottom of the conveyor frame. And then you also have to crack loose all the hardware that holds each of the side frames together with your spreader bars. I usually never like to see any skewed zones in ABEZ or other belted conveyors, but these little 2-foot sections don't seem to be too bad. We'll see over time. You can tell the difference just in how much the belt rubs on those versus all the other rollers. You may want to ignore the label on these ABEZ belts because they say bottom, which is confusing. But all you need to know is that the orange peel design, when it goes up top, it should be against the tread rollers, and the felt side should be against the pressure rollers. So here the belt is on the bottom, so the orange peel is facing the floor. Without DC power to the photo eyes and without ear, all the zones run. So in order to install the belts, we carry around a little compressor to charge up the system, and then a 120 volt cord. We just wire up one IOP and bring it around with us so that we can get those pressure plates off the belt, and it's easy to run those belts. So if you have loss of ear, nothing is going to accumulate. All your packages are going to pile up and start being thrown off the conveyor. So if it's done right, there should be an inline sensor so the PLC won't let the system run if there's lack of pressure. While we got the temporary IOP hooked up, that's when we align photo eyes. Align photo eyes to the center of the reflector, not just until the beam is made, because it might barely be on the reflector and then just one little bump, it's off, and it's annoying to have to keep going back and realigning photo eyes. Just align it to the center of the reflector once and be done. As long as we're talking about pet peeves, I don't like it when people cut this 3/8 poly tube a little too short and then they have to stretch it to get it into that solenoid, and then it just leaks a few days later after it starts pulling out. There should be a little bit of slack in it after you're done. And any poly tubing should be coming straight on, not at some sharp angle that causes it to leak. I think some people may not know the difference between a snub and a carry roller or return idler. A return idler, a belt doesn't have any wrap over, it just skims over the top, so 0-degree wrap. A snub is a roller that has something like 20-30-degree wrap, so you actually have heavier duty bearings because of the load of the belt going around it, and a snub has more tracking ability than a return idler, so that's what you're going to be using to track your belt. If the belt throughout the whole conveyor is off to one side of the conveyor, then you're going to start by using one of the snubs at the infeed or discharge near the end pulleys. And it's the snub that the belt gets to right before it goes around an end pulley that has the greatest tracking ability, versus the other end where the belt goes around the end pulley and then around the snub. And then you also have a snub at each end of the drive before and after the drive, and then a larger 11/16 hex shaft snubber in the drive. But you'll be using the snubs near the end pulleys first to track. While installing guardrail and flaring it, plan for worst case scenarios, so tens of thousands of packages that go through the system over the next few decades. Don't ever run into a catch point. If you install a conveyor for a living, you should be able to eliminate every catch point while building it, so you don't have 1,000 different catch points to eliminate during startup. That's annoying to have to keep fixing one little thing at a time. You can do it right and just be done with it. These tabs should be flared opposite each other ever so slightly on roller set low before you mount this bracket on. You got 3 spots you can get with a flathead screwdriver and 1 with the channel lock, and then you're golden. Anytime you go from having guardrail to not having guardrail to having guardrail, then you have to flare out so that you funnel everything back in and it doesn't hit here at the end. There they are. And then it's out in the walkway, so rounded these corners. Otherwise, somebody's thigh would be slit open. When we were building up on this pick module, we noticed between these 2 rack uprights that this whole floor had a dip in it right here. And it was because they aligned the tops of these beams, but one of the beams was welded on the bracket like 3/4 of an inch different from the other ones. So the bracket couldn't be aligned to the next. We had to actually raise that beam up to get that dip out of the floor. So everything that you're doing to a conveyor, straightening, squaring beds, leveling, is all within a degree of accuracy. But any little thing out of place does have an effect on the belt and can make it track off. So if you've got everything within tolerance but there's still little off-tracking forces, how does the belt self-correct? The end pulleys are crowned, so the slightly different diameter that's larger in the middle of the pulley creates center tracking forces to constantly correct the belt every time it does a revolution. The closer a conveyor's length and width are to each other, the more tracking issues you'll have. So upon startup, this short slider bed will be more difficult to track than a longer conveyor. But you'll still start with the snubs near the end pulleys. And just like we talked about before, the belt is going this way on the top, and then underside it comes around here and goes over this snub right before it goes around the end pulley. So this snub will have a greater tracking ability than the snub at the other end, because the belt goes around the end pulley right before it gets to the snub. I'm going crazy up here! You can sort of describe the way that works, because when a belt is close to an end pulley and you try to push it over, it doesn't move very much, but the further you are away from that, the same amount of pressure, you can easily manipulate that belt over. The closer a conveyor's width is to its length, the harder it is to track the belt. That's why if you got a belt that's 5 foot wide and 10 foot long, it's gonna be a nightmare. So good luck tracking that. So something like that, just like a feeder on an incline, the snubs hardly have any effect on the belt. So you're probably gonna end up having to use the end pulley to help you track. Right before you start up the conveyor for the first time, you're gonna go throughout and make sure that all your snubs, return idlers, and pulleys are all square. With these, you can just move the slop to one side on both sides of the conveyor, and you know it's pretty close to square. Here's an ABEZ line on top of the pick module for accumulation, and then we got some BZ right before this slider bed, and then off this pick module we got some more ABEZ before it gets down to this curve up here. Here's the bottom of the pick module, pretty much the same as the top, except a lot longer. Got a line of ABEZ, then some BZ, and then some slider bed before a couple of S curves, and then a roller bed incline. Got a bit of a rabbit trail for you. These Hytrol stickers last forever. You see them a decade or two later and they're still on and readable. Hopefully they haven't changed vendors. I need to find out who that is if I ever need a sticker. If you really want to make things look nice, I suppose you could order double spacers when you know that something's going from slider bed or roller set high over to roller set low. Then you got those long enough bolts to raise it up there. I stole that thought straight from Perry. I know it probably seems like I'm telling you way too much, but I do want to cover the details since that is what results in a quality installation. And there's so much I'm skipping over. Okay, maybe not. This is my shot list. Now where we had these roller set low and it went to roller set high, there was a transition plate from this 3-inch guardrail and this 6-inch. So it actually doesn't look too bad here. When mounting fixed channel guardrail, oh, squirrel. Hold on. I spy a shadow. Loose. Anyway, what was I saying? When you're mounting fixed channel guardrail, the side that faces down toward the conveyor is the side with slotted holes on 3-inch centers. So you always end up falling in place with a hole on the side frame for mounting. And you have plenty of options to mount the reflector straight across from the photo eye or 3 or 6 inches offset from the photo eye. Here it's all 6 inches back because it's liquor and it's in slug mode, so you don't want any packages drifting past the photo eyes. Order of operations, you got to install your fixed channel guardrail so you can get your reflectors up and photo eyes aligned before you install your belt, so it's easy to get those pressure plates off your belt. And before you install the fixed channel, you already need to know how far back the reflectors will be if they're going to be offset, so that you don't end up putting spacers right where you're going to be putting reflectors. On a belt, you can install hardware facing out on splice plates so that it doesn't rub on the belt, or you can just install shorter 3/4 inch bolts and they'll be just fine facing in. A really great idea Joseph tried out on this project was netting instead of belly pans, which is great because it's super quick to install. It isn't a nightmare like belly pans that run into your knee braces and into electrical brackets. Maintenance can see what's in there as bottles build up and they can take it down to clean it. So it's a lot cheaper and a better solution for the end user. Industry standard is to install coverings like this from 3 feet up to 7 feet, which is anywhere that is common for people to get underneath the conveyor. You don't want them to touch the belt. But if you have rollers on 6-inch centers like this incline, you could put netting underneath the whole conveyor so that you don't have little bottles falling through hitting people since you have a walk-through. Anytime you have a walk-through under conveyor, you can put foam overhead We've pulled this highway rail this way a little bit so that it diverts people around the shorter part of the incline, and then they don't hit their head underneath here. You want to keep highway safety rail about a foot away from stuff, and here we gave enough room, I think, to get this motor replaced without having to take apart the highway rail. Jam nuts on your take-up don't have to be tight. If there's tension on that belt, that nut is not loosening. We keep seeing this new style of black plug on these E24 cards damaged because these are mounted underneath a lot of the E24. And then it gets damaged during shipping. On the bottom of the pallet, they're just stacking them right on there, ripping this cord out. Boy, I sure do miss that green and black plug. Those served us well for decades. The most problems we have with bands are on E24 curves with rollers on 2-inch centers. Hytrol seems to be fixing the problem with these drive bands running into the next groove on the roller. They're making these deeper now and fixing the spacing or something there. But a lot of times you still have these bands rubbing on this plastic housing. But that's a pretty easy fix. Sometimes you end up having rollers bind up in these curves because the frames are too tight together. Sometimes you have to end up spacing that spreader bar apart a little bit more with a washer. If Hytrol hasn't already done it, you might have to add a few more washers. Oh, look, a nut. Anytime you find an issue like this with curves, it's best practice to just go check and fix it in every single curve in the building. It's way less annoying for the controls guy if you just fix any problems you can foresee instead of having to wait on him to keep telling you about one little dead zone or catch point. This support somehow got anchored when it wasn't perfectly vertical. If you put a laser on it, you can see it better. From top to bottom, it's probably off an inch. Here's the pick module. We got top and bottom level coming up to 12-foot top of roller. Coming around here, got a couple of goalposts for drive path. And then you got another couple declines here. And then it gets down to ground floor and you go to E24 curves. And it goes back into the blue room with some E24. Those two lines from the pick module come around through that wall and feed onto this merge right here. And then you also have two other pick lines, a bottle and a dynamic line, that feed onto this merge as well. This photo eye has two clips that come off here, and then these tabs pinch in, and this photo eye pops off. You have 8 pins on the back. If you have a problem with the zone, check several zones up and downstream to make sure those pins aren't bent, and they can plug into this strip in the back. And you can see the flow arrow here, so that if you end up having to mount your logic on the other side, you can turn that the correct direction so that it still goes according to flow. Flow is this way. Get on there as I bend the pins. Hopefully everybody already knows this, but this cable coming out of the photo eye goes over here and controls this card through this 3-pin plug. You have positive, negative here, power coming in for this board, and then several pins here, which you can look at the manual. I think one is the signal to run the motor, and then you got some other options. You got 4 LEDs right here that have different meanings, and then some dip switches, some of which are for speed and some direction of motor rotation. And then here's the cable going out to provide power to the motor. So easy logic photo eye, talking to the card, power to the card, power going out of the card to the motor. Usually the electrician scope to connect up this power supply. Here you got a gender changer providing power to this harness cable, which has all these little pigtails coming off to power up all the cards. So the power supply is providing power to the cards and the motors, not your photo eyes. Those harnesses just continually plug in at the seams, and then you have one power supply there and another power supply there, and you don't want them connected causing problems, so these two are unplugged here. Sometimes electricians will put electrical tape around it so somebody walking past won't say, oh, let me just plug this in real quick. They always sound like that when they plug it in. This aluminum box, your IOP, is what powers up all the photo eyes. You have this M12 T-harness cable coming out and an on-off switch here, and then that T-harness comes over here Same thing for the IOPs, just like the power supplies. You don't want this one to be connected to another IOP downstream. So at some point you'd break the connection, but they still have to talk to each other. So you actually plug in a 6-inch cable called a power isolation cable, so you can still have communication between photo eyes, but the two aluminum IOPs won't have power connected between them. When you're coming up on a merge or a sorter, you shouldn't even have to look at the order to see how the guardrail was ordered. You know that you want to have spacers in here so that photo eyes and reflectors can see each other, and you'll be saving the electrician's time from having to punch holes in all your guardrails. So that saved them punching something like 32 holes in here for, I think, 16 photo eyes and reflectors. Product flow is this way coming onto this merge, so you don't necessarily need these bull noses, but they do look nice. If this was a sorter and you were diverting off onto that spur, of course you would have both of those flared away from those side frames so that you wouldn't have product hitting that corner. Hey, let's not get into theoretical situations now. We already got a lot on our plate. If you're building everything first and then you're coming back to straighten square beds and all that, you're bound to have something like this. Yeah, you see it. There's a 1/2-inch gap right here, but that other side is almost closed. What really matters is each bed is square and the whole unit is straight. So that's not affecting function. Does it make me uncomfortable? Yes, but I've been uncomfortable for a long time. Just looking at this merge here reminds me of something. We had some good engineers on this project. I don't want your heads to swell, but you know who you are. All right, my mouth's getting dry and I'm starting to go a little crazy here with this, but it is quiet here, so it's nice. Here we got an LRC, a V-belt curve. I don't think many people know this, but there's a gauge right here on this tensioner so that you know when it's the correct tension on the V-belt. These little tabs sticking down have to be somewhere within this area right here. You can see the spring in there. And right here, you gotta get a 3/4 in here impact to loosen and tighten it. When you have good electricians like this, they're always staying away from things like this. So they squeezed on by for you to get an impact still. And they do other things like staying away from snubs and end pulley adjustments and takeups. See them go around this drive right here, all the way around it with the conduit. There are two different ways that a belt is run around these pulleys here. So if a belt pops off, take a look at the shape of the pulley. In one scenario, this is how the belt goes. It goes around this pulley and then behind this one and then in front of this one. In a different scenario, the belt would go on this side of all 3 pulleys. And you can tell the way the belt runs because the shape of the pulley. This pulley is flat for the flat side of the belt. This pulley is grooved and this pulley is flat. If the belt were going around this side of all these pulleys, all of them would be grooved. On all your V-belt curves, you'll have these black sheave pulleys to keep that belt moving around the outside of the curve. And you also need these sheave pulleys on any ACC or straight beds with V-belt if you're going to be skewing your rollers. You have to order it that way from Hytrol. Otherwise, it just comes with pressure rollers to push that V-belt up into the tread rollers. Here's a part of an ACC bed that has these sheaves to push the V-belt into the tread rollers because you got a motor there. But the rest of the bed has these pressure rollers that push that V-belt into the tread rollers. So this whole conveyor right here, you could not skew these rollers because it wasn't ordered with sheave pulleys to keep that V-belt in line while skewing. Unlike the tensioner on that LRC, here you actually have a pulley that changes position on here and changes how tight this V-belt is. Like I mentioned, on these shorter beds that you can't fit a turnbuckle on, you can use a ratchet strap to square. Aiden actually made this turnbuckle. You can see, cut it off and bent it just enough to get it to hold and square up. You got these dowels that are the spreaders between these frames on the curves. On this curve, the frames were too close together, pinching rollers, so we put this thread rod in so we can run those nuts out. Anytime you have a spur driving onto a merge belt like this, you're going to set that spur high. These rollers were actually set above some UHMW that was along here, and that UHMW was so wide that it was actually causing product to spin, so we got rid of that, but it's still high enough that even their smallest product will go from these rollers to that belt and never touch this metal frame here. Okay, maybe it'll kiss it as it slides by. Normally when you're building, you're putting the support right in the center of the seam. But when you get to a curve, the easier thing to do is to offset the support so you're only getting one hole on the side with the curve, because as soon as you start following that curve around, you start misaligning with your holes and maybe finding holes that are rolled closed a little bit. So that's a faster way to build. Sometimes when you're connecting up E24 to something, you'll see that they actually have something in the way so that a cord would have to plug in at a 90-degree angle. I've seen people try to plug this in super sharp like that and ruin it. The right thing to do is to cut that bracket so there's room for that cord there. When you're depalletizing and setting everything out on the floor, you want to think about the order of which you have to install so that you don't bury yourself. So here in that other room, we worked from that sorter all the way around this way, then this incline and back this way. And I wanted to get this merge done before we ended up building these spurs off of it, because you want to get this straight, anchored and everything set in stone before you start building off of it in this direction. But then you would also have this ABEZ trapped back here. So what we did is lay out this whole line right here against this wall, lay out that ABEZ line against that racking, and then Aiden and Charles had a good idea. Build this first, get it close to that endo, and if it ended up being off, we could shift it a little bit to meet up to this spur, and then work it from that sorter back here along this main line. And after the merge is done, work all these spurs and lines off of the merge. If you have a straight run with several different elevations or widths, like right here we have an incline, we have 24-inch wide conveyor, then this RB conveyor which is 30-something inches, and then another 24-inch wide section. The way you're going to straighten that is shoot a laser from that end down, and then you can straighten the top and bottom of that incline based off that laser. And then each of those sections you'll install a string on. So that's 1, 2, 3, 4 sections you'll have a string run along the side frame. So you got each point that your string is mounted to aligned with the laser, but then everything else between those points is going to be straightened based off that string, which makes it a lot easier and more accurate to straighten with that string. Any bed you're aligning with the laser, you're not aligning between the supports down here. That could be totally different from what your beds are up there. So you need a mark in the center of that frame on a bracket up there, like that black Sharpie mark right there, to align to the laser in real time, so you see if anything changes while you're straightening. That's accurate enough to align each end to that laser, but that wouldn't be accurate enough to line the underside of the entire conveyor to laser. You need a string on top. Remember how I said the closer the width of the conveyor is to the length, the harder it is to track the belt? Well, here we got a feeder belt, and what is that? 5 foot long and 20-inch wide belt? Well, here the snubs almost have no effect on that. You can try the snubs to track that first, but you're probably going to end up having to track with the end pulley there. And when you're building, you should be making sure these plates that hold the end pulleys are the same on the slop on both sides of the conveyor, so that that pulley is square with the bed frame. When you're squaring a drive like this, you can't get the turnbuckles underneath, so you'll be using a ratchet strap. But what you're going to have to do is loosen up all the hardware here, at least crack it loose, that mounts the drive to the underside of that bed frame. And then you're also going to have to loosen probably 5 or 6 of these spacer bars which run between the side frames of the conveyor. If your beds aren't squared properly, 1,000 slightly skewed rollers can have a greater tracking effect on a belt than a skewed snub roller. Yeah, I learned that the hard way. Like almost everything else I've learned. I was telling Aiden about a shaft mounted motor and reducer. You're not going to get that shaft perfectly centered and wobble free on that pulley when you make it, unless maybe you spend 10 times the amount trying to manufacture it. So this motor and reducer actually moves slightly with the wobble of the shaft, and you have these rubber or synthetic spacers to allow that wobble to occur. On one but not all of these RBIs, I noticed that 3/8 white bracket that holds the snub before and after the drive was just a rectangular shape, which is reversible if you put it upside down, and then a different one, it had a different shape which isn't reversible. If you put one side upside down, then that snub is super unlevel inside that drive. We noticed it on one when we were building, but if you see a belt tracking way off on one of these RBIs, maybe one of those brackets, keep an eye out for is reversed. If you plan on doing layout based off of column centers instead of your datum, you're gonna have to first go around the whole building and measure between columns and make sure they're not off from each other. Even when they are, for example, you find something that's not just 50 foot but 50 foot 1 inch, usually you can still run that center chalk line off of columns, and then when you get to it, you just run that conveyor parallel but off an inch from that chalk line. We'll do that quite often. You're probably starting your build at a critical point anyway. For example, here we started it near the sorters, but if one of your center lines is off, you'll see after you make a curve and you start running it, you'll see it's parallel to your chalk line instead of right in line with it. Here you see two center lines. One of the guys was doing layout and measured off of a nearby column, and then later double checked it by measuring off the datum column. He then assumed incorrectly that the datum column dimension was correct and the nearby column was incorrect. When you have two conflicting things, you can't just pick which one you think is right. You have to track down what went wrong on both and figure out why you got conflicting points. In reality, when he measured from the datum column, somebody burned 2 inches and somebody didn't add 2 inches when they put the tape down. So that was the incorrect dimension, and if it was measured correctly, the datum column and the nearby column would have agreed with this point. The point is, mistakes happen, but you can't be comfortable in walking away from a mistake without finding out exactly why it happened and how to prevent it in the future. In this case, you'd learn, okay, never burn 2 inches. That's hard to tell if you're off. Always burn 1 foot. You can easily tell if you're off 1 foot. Merges down there, then you have this ABEZ bottle line here, this RBI incline 12-foot support, and then ABEZ overhead running down that way. Here the end user is going to have a bunch of boxes being staged for this bottle line. So instead of highway rail coming all the way, they had us put bollards here so that forklifts don't try to go through here, but they can still stage some small pallets while still protecting all these uprights. Here we have 9-foot strong backs for these two drive paths because we have 15 foot between supports. It was attempted to use those little 1.5 inch angle iron brackets, but that distance between caused that to sag about 1/2 inch at the seam. There's our blue aluminum fast pipe providing air to the ABEZ. After this single line of ABEZ, you got an RBI decline. When building these heavy duty supports, you have to have them laying down on some sort of platform. If you're laying them down on the floor, your smiley and your foot plate will both be against the floor, and then this middle section will actually have enough slop to let that support bow before you tighten up hardware. So then all your supports would just look like a subtle rainbow, which would look silly, but pretty. Sometimes the slave drive on these inclines and declines, the chain can't be the perfect length and you have no adjustment. Sometimes it has slack and ends up dragging on this 3/8 bolt. So sometimes you can slide on a UHMW dowel we have on the truck. Here's the pneumatic system we put in, rapid fast pipe with 2 Kaeser air tower compressors. These screw compressors are nice because they keep cool and have 100% duty cycle, air on demand as they say. The reciprocating compressors have something like a 60% duty cycle and get up temperatures close to 400 some Fahrenheit. Here we got a ball valve coming out of the compressor, a union so you can take this off and service your filter, as well as take this fitting off here. Got a drain here so you can shut off this compressor from your pipe and still run this second compressor. Drain your air on this side of the filter so air flows through, and then you got a dryer in here so the condensate comes out through this 3/8 poly tube. That poly tube runs over here into this oil water separator, KCF 25. Somebody took our 5-gallon bucket away. Normally everything you do around the compressors is 1-inch hose. After all, you're already at 1/2 inch NBT going through this filter, and then the 1-inch hose allows you to have everything in a smaller area without taking up so much room. We already had this 2-inch pipe on the truck. I was trying to get rid of it, so that's what we used. And then we come up here and we split off there at a T, and this goes around the building in this direction. Here I ran and cut across all these 6 lanes of conveyor so that I could saddle drop in 6 different places for some ABEZ and then this sorter. And you can sort of see what you do is come out of that saddle drop with 1/2-inch barbed fitting to that black flex hose, go up to the steel web joist, get a strain relief on there, and then drop your hose down to your conveyor. And boy, doesn't that look level across here. Thank you, Hilti Rotary Laser. If you need air before Kaeser comes and commissions, you might want to ask their permission. But here you got 3-phase 460 coming in, and then you got 110 coming into this 4FU, and neutral and ground there as well. And then this transformer, they don't connect up until they commission. You see right here, no connect on this pin right here, and that will move over to whatever power you got providing. So it'd look like that for us since we got 460. These are nice, so if the phase is backwards, on this it was, so I had to swap it. On some of the old compressors, you might have to check if the fan is rotating in the correct direction. But here you don't have to. A lot on these new ones, it'll just put up a code that says wrong direction or phases incorrect or whatever. So you would just swap 2 legs on that 3-phase. Here they put in Boyd just across, so brown, orange, yellow. So now it's brown, yellow, orange there. Here you have a PROSORT MRT diverts, and it's nice they send these belts vulcanized from factory. So you got these cutouts on the side that let you slide that belt down through that crack there, and then the end pulley down there, you just unbolt each of them, slide the belt around, and then bolt them back. These pop-up diverts require 60 psi, and here's an air sensor for the PLC. Got 1 FRL per divert supplying this trunk line along here. So here's your trunk line providing 60 psi to the diverts, and here's 120 psi coming from the compressor. Got a pneumatic take-up, which you can't really see down in there. Takes 15 to 20 psi, and you adjust it based on whatever it takes to move your product. Less tension will put less strain on the bearings, drive, and any other moving parts. We got a ball valve before we split off to go to the take-up FRL and the divert FRLs. When you're setting height on these spurs, you want to set it level, or if anything, just a touch below your diverts when they're popped up. So when you're building, you're gonna just pop this divert up by hand, fully extend those cylinders, and then come across here. You can see how high we have these, and everything seems to be transferring on nicely. Remember how I talked about having spacers whenever you have a merge or a sorter? Well, everything has spacers, but this one piece was a different height, so it got mounted down on the conveyor frame. So really function over fashion, I would have mounted this up a little bit with spacers. It wouldn't have looked as good up here, but who cares? It saves the electricians time from punching all these holes through it for the reflectors and photo eyes. You see here too, having to punch holes. I'll tell you, the way you set these nose overs on these inclines and declines, I didn't know for quite some time. So these both have a lot of slop, and you're gonna set this position, the height, based on a 4-foot level that's going across this bed. Then the same thing, 4-foot level across this bed, set the height on this roller. And if you do that, then you won't have product bumping as it comes up and around here. This roller in the middle actually will not touch the belt. If you look down, there's a 1/16 inch between the belt and the roller. Sometimes it's 3/16, and then that only hits if you have some heavy box that pushes that belt into that roller. There's no more adjustability after you've set this roller and this roller, so this one just falls into place. This is how the guardrail pans work on the nose overs. You have a shorter pan right here, and it mounts on the outside of the frame. You can see it over here sticking out, so flow goes this way. You don't hit this edge here. And then you have a larger plate with 2 rounded ends here. You can see it here. It goes behind this plate and in front of the next one. Then you have another plate, and this one mounts on the inside, unlike this one that mounted on the outside. That way you have continuous flow and no edges to hit. And there's just one less piece when you're down at the feeder end. So you have that one bracket mounted on the outside, and then the next one mounted on the inside. So you got this sorter, PROSORT MRT, 2 down lanes. They run all the way down, have a loop. Then they both come down this way and both drive onto these two Stewart Glapat truck loaders. And then at the end of the PROSORT MRT, you have a decline, goes down to the floor, and it's a hospital lane coming down under here and discharges between these two truck loaders. You need to have 36 inches between a control panel and anything else like highway guardrail. We mounted this too close at first. The supports on top of this truck loader we flipped upside down because this angle iron was right above that belt. It wasn't rubbing, but a hand could have got sucked in between the belt and the angle easily. And then we flipped these smileys facing out. Usually these belts track pretty well, but why not give it a little bit more play in there? And then you got to tack weld your feet down because that next boom is within a 1/16 right underneath this plate, so you can't tack screw down into there. After this herringbone, you got a little transition plate and it pivots. I like to weld it right there so that it doesn't rub that belt raw. I didn't realize there was slop in this bolt hole, and so I welded it crooked. It was enough to drive me crazy, and I was surprised the end user even noticed it. Got it right on this one. This truck loader has 3 sets of feet on each side. In the front, 2 near the dock door, you're just gonna have 5/8 wedge anchors, but in the back here you gotta have Hilti epoxy anchors. It was supposed to mount pretty close to this relief cut. I think the minimum for this size is like 2 3/4, but we ended up just bringing it back 7 inches to get it away from there. Again, you can't drill all the way through the concrete, so your epoxy drips out the bottom. That covers it for this video. If you have any questions, let me know, and take care. Harder and smarter. 2 at a time. Like getting all the groceries out of Mom's car at once.